All right, this is Coach Williams, and we are going over the 6.1 notes. Here we're going to be dealing with powers or exponents and a base, which is going to be our number that we're going to multiply times itself, and we'll get into that in our vocabulary here pretty quick. And then also a little bit of scientific notation. First thing we want to discuss is just a power or an exponent, which are really going to be somewhat the same thing. So your power and your exponent are pretty much the same thing. I'll give you a demonstration out here to the right. We're going to have 4 raised to the exponent or the power of 2. All right, so this is the power. We also call this the exponent. Okay, so 4 is being raised to that power. This number here, 4, is our base. And what this simply means is we're going to take 4 and we're going to multiply 4 by itself however many times the power or the exponent tells us to do that. And again, in this case, it's going to be 2 times. So we're going to take 4 times 4, and that gives us a value of 16. So a power, if we want to try to put this into words, I guess you could say, this is going to be, and this is the Coach Williams version of the definition, this is a number that says how many times tells us how many times to multiply the base number by itself. Again, how many times am I going to multiply 4 by itself? I'm going to multiply it 2 times. So 4 times 4. And that's, you know, kind of just a brief definition of, not necessarily an exact definition, but it's kind of the Coach Williams version of the definition. It's a number that tells us how many times we're going to multiply this base number 4 by itself. And in this case, it's 2. If it was 4 to the 3rd power or to the exponent of 3, then we would have 4 times 4 times 4, and we'd end up with 64. So that's kind of an explanation here of powers and exponents. The base, we've already kind of discussed it here. We've shown you an example. The base is the number, again in Coach Williams' version of the dictionary here, there's a number being multiplied by itself, and then how many times? It is the exponent or the power number of times. So if the exponent of the power is 3, then I'm going to multiply by itself 3 times. So that's kind of using the vocabulary from this to make the definition for base, and obviously using base in the definition of power. But we see the example here that gives us a little more information about it. All right, scientific notation, and we'll see more examples of this in a few minutes. It's going to be pretty simple. The scientific notation is when we use the power of 10. Okay, so we're going to use using the power of 10. To write larger numbers, well, let's do this, larger numbers more efficiently. Again, this is kind of the Coach Williams version of that. We're using the power of 10 to write large numbers more efficiently. Or maybe they are small numbers. So very small or very large numbers more efficiently. All right, now I'll give you an example of that. If we were to take the number 2,620,000 and we wanted to write that in scientific notation, Well, then we just take tens, the power of 10, or the, zero. We're just basically taking zeros off or decimal places off to get this number down to a smaller number. We would use this scientific notation. We could write this as 2.62 times 10 to the however many times we move the decimal to get to the in front of this, or between the 2 and the 6 here. So we move this decimal place 1, 2, 3, 4, 5, 6 times. Okay, we moved it 6 times. Then we would say that this is 2.62 times 10 to the 6th power, or the exponent of 6. Okay, so a rather large number, and this may have 20 or 30 zeros, or even more than that. We could write this more efficiently or more effectively as a smaller number times 10 to some power versus having to write out 20 or 30 zeros. Going the opposite direction, if we had a number, let's say it was 0.000262, then we could write this also in scientific notation, and this would be 2.62 times 10, but in this case, we actually went backwards. And when we go backwards, this was a positive 6. What do you think this one's going to be here? It's going to be a negative number. So we're going to have to go back 1, 2, 3, 4 times. Okay? And so this is times 10 to the negative 4, because we actually went backwards 10 decimal places, we'll say, 10 spots there. And so we could write this as 2.62 as 10 to the negative 4th, and that would save us again from writing this large number and having to write, in more extreme cases, there may be 10 or 15 or 20 zeros. So scientific notation just helps us write these extremely large or extremely small numbers a little bit more efficiently or effectively. Okay, moving on to core concepts involving these exponents. The first thing we're going to learn about is the zero exponent. And the zero exponent is always going to be an answer of 1 as long as the base is not a 0. So the base number in this case being a 4 raised to the 0 power is always going to be 1. For any non-zero number a raised to the 0 power, you're always going to get 1. And I know that kind of boggles the mind at times, and so I try to think of a best way to explain this here. And just bear with me as we write down a few things here. 4 to all of these powers, and this hopefully will give you a little better concept. We talk about factors of numbers, and the smallest number of factors that an integer can have, I guess, at this moment we'll call it, is 2, and that's a prime number has 2 factors. That's the smallest number of factors. Some have 2 and 3 and 4 and 5 and 6 and 20. But whenever you get down to the smaller factors in a number, the smallest you can have is 2. And a prime number is the factors are 1 and itself. So with everything, you always have 1 as a factor involved in the output number or the value itself. So if you're thinking about that and you apply that rule, that 1's always involved, and you have 4 to the 3rd power. I'm going to go backwards and get back to 0, and hopefully the concept starts to reveal itself here. 1 times, if I'm listing the factors of this answer, I'm going to have 1 times 4 times 4 times 4. And we found out a while ago, we talked about it, 4 to the 3rd power. This was squared at the top, gave us 16. We multiply that times 4 one more time, we end up with 64. And again, this is just in terms of the power rule here, we're listing 1 and then all of the 4s that it takes to get to 64. If we're doing the powers, using the power rule here with 2, we're going to have 1 times 4 times 4. And so 1 times 4 times 4 is just going to be 16. And here you're going to have 1 times, how many 4s would I list now? 1 4. Okay? And then 1 times 4 is just 4. And then I'm going to have 1 times how many 4s? 0 fours. So in this case, I just have 1 times, that's it. It's not 0, it's just 1. So anything raised to the 0 power is 1 times none of those bases being multiplied, so you always end up with a 1. Maybe that's the easiest way to explain it, I guess, for now. Maybe we'll come up with a little more fancy way of doing it, but I think this pretty much gives us the idea of the concept of why anything to the 0 power is just 1. Okay, and then we know by the concept here, it shows that any 0 raised to the 0 power is undefined. So you can't be a 0. The base itself can't be 0. It has to be a non-zero integer. All right, so that rule out of the way. Let's move to the next one. Negative exponents. When we're dealing with negative exponents, we're going to have to remember reciprocals. And basically, we just got to put it in a fraction form and flip the fraction is maybe the simplest way to explain that. So, for any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. So it would just be 1 over a to the n, and they show that to you here. As an example, if I had 4 to the negative 2, then I would take 4 over 1, take that right there, I would flip that fraction, or take the reciprocal, and then I would apply the power, or the exponent, without the negative. The negative just tells me to flip the fraction, or to take the reciprocal. And then I apply the power. So then I'll have 1 over 4 to the second power. Okay, and we'll see more examples of that in just a minute. But again, just kind of algebraically, a to the negative n is going to be 1 over a to the nth power. Okay, as long as a doesn't equal 0, because again, if a is 0, you could end up with a situation where it would be undefined. Okay, let's look at the product of powers property. A lot of p's in there. So the product of powers property just says that whenever we've got the same base and we're multiplying two bases with different powers or even the same powers, but we've got those raised to exponents or powers, then we will add the powers together. We'll add the powers together as long as it's the same base. So now this 4 to the 6 times 4 to the third is going to end up being 4 to the 6 plus 3. And 4 to the 6 plus 3 is the same thing as 4 to the 9th power. So if we're multiplying and we have the same base, we can just add the powers together, combine those, and then we can simplify that if we needed to with a calculator. All right, so a to the m times a to the n. Notice a is the same base. We can just add m and n together, and we come up with the answer there. Okay, that is products or multiplication. So when we multiply, we're adding. When we are dividing, we subtract. Okay, you'll see this right here. We're subtracting 6 from 3. Okay, again, it has to be the same base. This doesn't work if this number's 4 and that number's 5 or 3 or 6. It has to be the same number. But as long as they are the same number, we can just simply take 6, subtract 3, and 4 to the 6 minus 3 is the same thing as 4 to the third power, or to the exponent of 3, and then we can solve for that if we need to using the calculator or multiplying that out. Again, same base, a has to be the same, and then whatever numbers we have here, we can just subtract them, and that will help us get to a more simplified version of that power. Okay, flip the page. We also have a power of a power property. Okay, so if we've got a number raised to the power, and then that whole thing raised to a power, so basically we have a power to a power here, or a power of a power, then you actually are going to multiply those numbers together. So the 6 and 3, we multiply together. So 4 to the 6th raised to the third power. Okay, so we have a power of a power. Means that we're going to have 4 to the 6 times 3, or 4 to the 18th power. Okay. Again, algebraically, if we have a to the m raised to the nth power, it's just going to be a to the m times n. Okay, and as we said, we're going to go through some examples of this in just a minute, which are going to make this pretty easy. Power of a product property. So if we're applying a power to a product of two integers, or two numbers here, then you could actually, somewhat like distribution, you could distribute this power to each factor inside this product here. You could take 3 to the 5th, which we see right here, times 2 to the 5th, which we see right there. So we could actually apply this power to all the terms inside the product, and you will get the same answer. So you could take this 3 to the 5th and find out what that is, multiply it times 2 to the 5th, and you would get the answer there. Okay. Now, when you're dealing with integers, obviously, if you just multiply 3 times 2, raise it to the 5th power, you could get your answer. But when we're dealing with algebraic situations where we have variables, then that's going to come in handy to pull those apart and apply those powers to them. All right, the power of a quotient. Again, this is going to be very similar to the power of a product. You're just going to apply the 5th power to 3 and the 5th power to 2. So you have 3 to the 5th over 2 to the 5th. Again, very, very simple to kind of put that together. Let's look at some extra practice problems here and see if it doesn't begin to make some good sense. Again, we've talked about this. To the 0th power, anything to the 0 power is 1. So it doesn't matter what number we have as the base, that is going to be a 1. All right, what about negative 2 to the 0 power? Again, doesn't matter what the base is, this is going to be a 1. Okay, now we have a negative power. We have a negative power. So I like to do this at first until we start to just automatically do it in our brains here, but let's put that 3 over 1. This is my base. That's my base, and I'm going to multiply however many times the exponent tells me to. But in this case, I have a negative, right? So that means I have to take the reciprocal. And then apply the power without the negative sign. So this is the same thing as 1 over 3 to the 4th power. 1 over 3 to the 4th power. And I could leave it like this, just evaluating the expression if I wanted to find out the actual answer to that. 3 to the 4th power is going to be 81. So you could also rewrite this as 1 over 81. If you want to get technical and you put it in decimal form, you could also go further and do that as well. Okay. The next one is also to a negative power. And so we're going to take this negative 4 over 1. We're going to flip the base, apply the power without the negative sign. So we're going to flip the base, 1 over negative 4. And then we're going to apply the power without the negative sign. And I like to do this as well because I want you to get in the habit of seeing it like this, because when you begin to use the calculator, you're going to need to put any negative base in parentheses. And the reason is you put a negative 4 raised to an odd power in the calculator, it's going to be negative, which it should be. But if you put a negative base to a even number power, it's still going to be negative because the calculator sees it as negative 4 to the 4th power. So it's going to take 4 to the 4th power and then put a negative sign on it. But if you put it in parentheses, then it's going to raise negative 4 to the 3rd power instead, and that'll get you out of trouble with negative signs whenever you get to actually, solving these, finding actual answers in the calculator. Okay. So again, this is going to end up being negative 4 to the 3rd power. It's an odd number exponent, and so our answer is going to be negative. And so if you multiplied that out, you'd end up with a 1 over negative 64. Okay, it's kind of a general rule of thumb to remember too. If you have a negative number and you have an even exponent, it's going to be positive. If you have an odd exponent, it'll be negative. Okay, Number 5 is an easy one for us because the base is going to go away pretty fast. What's the base going to end up being? I mean, not the base, but the denominator. 1. Yeah, that's just going to be a 1. So now I've just got 2 over 1 raised to the negative third power. So what's my first step? I'm going to take the reciprocal, right? I've got a negative. I take the reciprocal, and then I raise it to the power without the sign. So 1 over 2 cubed. And 2 cubed is just 8. 1 over 2 times 2 times 2. So that's just going to be simply 1 over 8. And again, you can put that in the calculator if you want to get the decimal version. All right, on number 6, we'll begin to have to do a little bit of work here. And something I like to do in the beginning until you start to recognize this, more quickly, is I like to break up a quotient into its parts and then work with each part and then put it all back together. And you'll see that it might be a little simpler to see the factors and what you're doing to each thing as you move along if it's broken into these parts and pieces. So this is actually, if you'll follow along here, this is actually the same thing as negative 3 to the negative 2 over 1 times 1 over 2 to the negative 3. Do you agree with that? I mean, if I multiplied across the top, I'd end up with the negative 3 to the negative 2 power. If I multiply across the bottom, I end up with 2 to the negative 3. So I haven't changed anything. I've just broken it into its pieces or its factors, right? So now, can I take this and simplify it, right? I can evaluate just this part right here. This is my base, the negative 3 over 1, raised to the negative 2 power, means what am I going to do with this? Flip it. 1 over negative 3. And then what do? Raise it to the second power without the negative sign. I've already taken care of the negative. The negative was just telling me to flip it. Then I'm going to multiply it times the other part. Again, I'm raising 1/2 to this 1 over 2 to the negative 3, so I've got to flip that 1/2, 2 over 1, and then apply the power without the negative sign. So I'm 2 to the third. Okay? So now, again, this is a negative. I want to put that in parentheses. Because if I take negative 3 and square it, that should be a positive number. But if I put that in the calculator without parentheses, it's going to give me a negative number. Okay, so what is 2 cubed? 2 times 2 is 4. 4 times 2 is 8. So I'll have 8 on the top. And on the bottom, I'm taking a negative 3, and I'm squaring that. So I end up with a positive 9. And that's my answer. The next two go pretty quick because, again, anything raised to the 0 power is 1. So I've just got 4 over 1 raised to the negative 1 power. The negative tells me to flip it. 1 over 4 raised to the positive 1 power. And that's just the same thing as 1 over 4. And number 8, I've got negative 5 to the 0 power. That's a 1. And then again, I've got 3 over 1 raised to the negative 1 power, which is just going to be flipped over raised to the 1 power, which is just simply 1/3. Okay? Let's flip the page and let's deal with some of our algebraic expressions. It tells us here to simplify the expression, write your answer using only positive exponents. So we're going to end up with some exponents that may be negative when we get done, evaluating these, simplifying these. And so we're going to have to make sure that all of our exponents end up being positive. All right, well, the first one is pretty simple. Z to the 0 power is going to be what? 1. Doesn't matter what the number is, anything to the 0 power, as long as z is not 0 itself, it's going to be a 1. Then we're going to have a to the negative 8 power. And a to the negative 8 power is the same thing as a over 1 to the negative 8 power, which simply means the negative sign tells us we're going to do what? We're going to flip it. So it's going to be 1 over 8. So we're going to have 1 over a to the positive 8 power. And as long as it's positive, we can leave it in that form. We're done. Okay? It's a positive exponent. We don't know what a is, so we can't simplify that any further. Okay? The next one, we've got 6 times a to the 0 times b to the negative 2. Again, let's break this into pieces. We're going to have 6 times, what's a to the 0? 1. And b to the negative 2 is the same thing as b over 1 to the negative 2. And the negative sign tells us to flip it and then raise it to the power without the negative. And so this is what we have. 6 times 1 over b to the negative 2, or b squared. And so 6 times 1 times 1 is just 6 on the top. And if you had these all over 1 here, b squared times 1 gives us b squared on the bottom. And that's my answer. The powers are positive, so we can leave it in that form. 6 over b squared. Okay, on to number 12. Number 12 is going to be 14 times m to the negative 4. Same thing as m over 1 to the negative 4, right? So we're going to take and flip that. So we're going to have 1 over m to the 4th power. All right, and then we're going to have n to the 0, which is just a 1. So we can just put 1 over 1 if we want to. All right, we'll multiply across the top. 14 times 1, which is 14. And this is the same thing as 14 over 1. 1 times m to the 4th times 1 is simply m to the 4th power. All exponents are positive. We're in good shape. Okay, let's look at number 13. Number 13, once again, they kind of help us out a little bit. This s to the 0 power is going to be what? A 1. So I can just do away with the whole quotient thing now and just deal with 3 to the negative 2 and r to the negative 3. Okay, well, if I write those two out, 3 over 1 to the negative 2 is the same thing as 1 over 3 squared. And then I'm going to take care of this r to the negative 3. Well, r over 1 to the negative 3, same thing as 1 over r to the 3, or to the 3rd power. Okay, everybody see what I did? I just flipped it, applied the exponent without the negative. Flipped that one, applied the exponent without the negative. Multiplying across the top, multiplying across the bottom, I end up with 1 over 3 squared is 9r cubed. Does that make sense to everyone so far? Mostly, I'm hearing. Okay. Well, mostly is better than not really. I like mostly a whole lot better than not really, and a whole lot better than not at all. All right, looking at number 14. Again, I'm going to break this up into pieces, and this one's a little bit longer, so I'm going to make some room here. But you're going to be able to do this in your head so fast after you practice this a few times. But I think it's important to see this one broken up at least once. We see a large one broken up into pieces. That way, we see the individual parts happening. I think if we can see all that happening a few times, then we'll begin to imagine it ourselves without having to write it all down. But if you look at this right here, I'm going to take each piece and break it out. Okay, so the first one, I've got 2 to the third over 1. Okay, this is going to be equal to the same thing. The next factor, okay, that takes care of that one. The next factor I have is a to the negative 3 all over 1. And then, that takes care of that one. This is the same thing as 1 over 8 to the negative 1. 1 over 8 to the negative 1. Okay, if you think about this, and we broke this all apart, let me finish writing it, and then I think it'll make more sense, because when we see it, we multiply across the top, multiply across the bottom, you'll see that it'll actually end up being the same thing. Okay, this is the same thing as 1 over b to the negative 5. And then, of course, the last one is the same thing as 1 over c to the 0. We know that's going to go away in just a minute. But if you look at this right here, look at how if I took and multiplied all the way across the top, I end up with 2 cubed a to the negative 3. If I multiplied all the way across the bottom, I end up with 8 to the negative 1, b to the negative 5, c to the 0. Okay, all I've done is just break them into the factors, the individual factors and terms themselves. Now again, you don't have to do this every time. You're going to be able to see this and recognize it, but I want you to see the individual parts changing at least once so that you can kind of have that visual in your mind. Now if we take this right here and work each part individually, 2 to the third, it just stays on top. It doesn't move. We end up with 2 to the third over 1. That doesn't do anything. A to the negative 3 is 1 over a cubed. So that one's gone, that one's gone. Working with the next term, 1 over a to the negative 1 is the same thing as flipping 1 over 8. So we get 8 over 1. We take it to the same power without the negative sign. So that one's taken care of. The next term, we've got 1 over b to the negative 5th. We take this base, we flip it, and we end up with b over 1 to the 5th power without the negative sign. That one's taken care of. And the last one we know is just going to be a 1 over 1, because anything to the 0 power is just 1. So now we've put everything in a positive exponent position. Now we can apply, or we can evaluate this and simplify it down. So 2 cubed is 8. 2 times 2 is 4. Times 2 is 8. 8 times 1 times 8. 8 to the 1 is just 8 to the first power is just 8, right? So 8 times 8 is 64. Times b to the 5th times 1. You're going to end up with 64b to the 5th power. And that's all the top. Now all the bottom is going to be 1 times a cubed, or a to the 3rd power, right? Times 1 times 1 times 1 just leaves me with a cubed. And that's my answer. Everything's in positive form. All my exponents are in positive form. And so I'm done with that one there. And again, if I were to just look at this and think about it, the 2 cubed is going to stay on top. That a is going to go to the bottom and be an a cubed. And then this 8 is going to be to raise to the top because it's got a negative. The b is going to go to the top because it's got a negative. And the c is just going to become a 1 and go away. So you'll be able to recognize those pretty quick. I mean, I could have just looked at it and said, okay, 2 cubed on the top, that's 8. A cubed is going to go on the bottom. 8's going to go back on the top. B to the 5th is going to go on the top. And that's just a 1, so it goes away. And then real fast, I would come up with 64b to the 5th all over a cubed. Okay, so like I said, after you get to recognizing what's going to happen here, it'll go much faster, and you don't have to break it out into these pieces. All right, let's move on to 15. Number 15, we've got the same base. If this is a quotient using the same base, different powers here. We're going to, because we're using the quotient property here, we're going to subtract the powers. So this is the same thing as 3 to the 5 minus 3. It's the same thing as 3 to the second power, which is just 9. Okay? Same base, so we can just subtract the powers. We can go from there. Here we've got the same base. We can subtract the powers. We've got negative 2 in parentheses to the 7 minus 5 power, to the exponent of 7 minus 5. So it's going to be negative 2 to the second power, or negative 2 squared, which again we know is just going to be 4. Okay, this is the product, and so all we have to remember is that we can add our exponents because we have the same base. So we can add our exponents. We can say negative 5 is going to be raised to the power of 3 plus 3. And the power of 3 plus 3 is the power of 6. So we have negative 5 raised to the power of 6. Alright, so then if we wanted to find that, we could actually put that in the calculator. We'd end up with, because it's a positive, an even property, it's going to be a positive number or result. It's going to end up being 15,625, I believe, if our calculator is correct. Negative 5 times 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 negative 5. Should end up being 15,625. Okay. Moving on to number 18. Number 18, we have the power of a power. Okay, so we have q to the 5th power raised to the 3rd power. So that just means we're going to take these numbers and multiply them. So this is q raised to the 5 times 3 power. Or the same thing would be q to the 15th power. Q to the 15th power. This is the power of a power, so we multiply those two together. 19 is going to be very similar. You're going to have a, you're going to multiply negative 4 times 2 to the negative 4 times 2 power. And so we have a to the negative 8th power, but we can't leave it in that form because it's a negative exponent. So what do? We take the a, we take the reciprocal. You're correct. We're going to take 1 over a to the 8th power, and that will leave it in the positive form of exponent so that we can leave it in that answer form. Lastly here for number 20, and then we'll finish these out here. We got a multiplication across the top, same base. So we're going to have 4 plus 3. So we'll have c to the 7th all over c to the 6th. And then now we have a division or a quotient. And so we're going to have c to the 7 minus 6 power. And c to the 7 minus 6 power is just c to the 1st power, which just ends up being c. Okay, last 3 examples for this set of notes. Number 21, we have a product raised to a power. So we could actually take this and we could separate it out. We could say, well, this is the same thing as negative 4 to the 4th power times d to the 4th power. And then when we take negative 4 to the 4th power, again, I would put that negative 4 in parentheses if possible. So when we put it in the calculator, it gives us the correct answer here. Then we're going to end up with 128 times d to the 4th power, or just simply 128 d to the 4th. Okay, on number 22, there's a couple of ways that you could actually work this problem. You could take the negative 3 and apply it to each term and separate it out and multiply it. But if you think about this, before we do that, this is to the negative 3 power. We could also take this base over 1, flip it, so it's 1 over negative 3f and apply the power. Okay? Now we can take and apply this 3 to each term on the inside, and we could separate it out as a product here. So we're going to have 1 over negative 3 to the third times f to the third. And if we do that, negative 3 to the third power is going to be 1 over negative 27f to the third power. 1 over negative 27f to the third power. Last example we've got here is 4 over x to the negative third. Again, we could take this base, and I think the simplest way to address this one is to flip the base or take the reciprocal. So it's x over 4, and then apply the power without the sign, the negative sign. And then here, we just apply the power to the x, apply the power to the 4. And so we're going to have x cubed all over 4 cubed. And we already found out 4 cubed was 64 on the previous page. And so this is going to be x cubed all over 64. And that's the answer to number 23. Alright, I hope these notes have helped you, and we will follow this video up with the next section on 6.2, where we're going to deal with radicals and a little different way of expressing radicals in the form of an exponent or a power. Alright, hope this has helped. You guys have a great day.